Hello viewers, you are welcome back to the channel. Subscribe and share it to others. Let's continue from where we ended, but before that we have a question to solve. So let us apply what we've learned from the previous lectures under the dimensions of basic or fundamental quantities and the derived quantities. Okay, so the question reads, find the dimensions of the following quantities. We have velocity, so let's deal with that. So solution, we have velocity, we learned that for such quantities, you have to write the quantity and express it mathematically. Then the next thing to do is just take dimensions on both sides, and that's all. So velocity is what? Is displacement over the time. So what do you do next? You will take the dimension. So do this way too. Please, this is very necessary, the square bracket, to mean that I'm taking the dimension of the quantity. Put this in square brackets. I'll put this in what? In square brackets. So to be velocity equals displacement. Remember, distance, displacement, radius, height, width, circumference, diameter form part of the separation, and the dimension for separation is denoted by what? Capital L. Since this form part of separation, so the dimension for displacement is what? Is capital L over time. What's the dimension for time? Is what? Is capital T. And according to the law of indices, this will be Lt to the power -1. Because I have my L here. When I transpose the T over here, the exponent will be negated. So this is the first part of the question. Let's consider the acceleration. So for acceleration, we have, so let's express acceleration mathematically. Acceleration is equal to what? We have the velocity over what? Over the time taken. I want to take the dimension of acceleration. So what do I do? I'll put it in square bracket. So I'll do it this way, this way, this way. Then acceleration, velocity. Do you remember the dimension for velocity? You said the dimension for velocity is what? Is L t to the power -1 all over the dimension for time is what? Is capital T. So now, according to the law of physics, when I have A, B over C, this is the same as A, B, C to the power -1. So here to the power 1, when I transpose this here, to be negated. Are you okay? So when this T also comes here, it will be acceleration will become, I have my L, I have my T to the power -1. Well, this will come here, so it will be T to the power -1 because it's positive. When I transpose it to be negative. So finally, the dimension for acceleration is what? L. According to the law of indices, when the same base are multiplying, I'll add the exponents. See, they are multiplying, so it will be T to the power -12. So as simple as that. Are you okay? Okay. Let's consider the third part. Force. So force mathematically can be expressed as force is what? Force is mass times what? Acceleration. Are you okay? So I'll put this in square brackets. I'll put this in square brackets. I'll put this in square brackets. Then my force, dimension for force will be, the dimension for mass is what? Capital what? M times, you can represent the dot to mean that you are multiplying, okay? Or you can say times, they are the same. Acceleration, what's the dimension for acceleration is what? Is L t to the power negative 2. Then finally, the dimension of the force becomes mass. So you have a M L t to the power negative 2. And it's very correct. So this is the dimension for force. Let's consider the fourth one, which is what? Work. Let's see how it goes. I have work done or work is given by the formula force times what? Distance. Move in the direction of the force. I take the dimension on both sides, this, and that. Force. What's the dimension for force? You know that force is what? It's mass times acceleration. Acceleration is what? Lt to the power negative 2. This for force. Mass times acceleration. This acceleration, this mass. Times distance is separation, which is what? L. So it will be M. I can see 2L here, so it will be L what? Squared. Then I have T to the power negative 2. So this is the dimension for what? For work, what done, or work. That's it. Are you okay? Let's consider the last part of the question. What's the dimension for pressure? Pressure. So pressure is what? Force on what? On area. Are you okay? I'll put this in square brackets. I'll put this in what? Square bracket. I'll put this in what? In square brackets. So my pressure. What is the dimension for force? Remember, force is what? Don't chew it. Force is mass, which is acceleration. You know that acceleration is what? Lt to the power negative 2. This is the dimension for what? For force over. That's the dimension for area. Area is what? Length times breadth. So LL. So L what? Squared. Are you okay? This you can play with your mathematical antics over here. This is the same as M L then T to the power negative 2. Are you okay? Over. You know that L squared is the same as what? L times what? Times L. So this L can cancel this L. So what do I have? I have M T to the power negative 2 over what? Over L. According to the law of indices, pressure is equal to what? I have my M. Please, conventionally, L will come before the T, okay? So here will be L to the power negative 1, then T to the power negative 2. This is the power positive 1. When it comes here to be negative, but L will have to come before the T. That's the reason over here. Are you okay? If you know that your mass is very strong over here, simply, you know that when you get here, you have your M, L, T to the power negative 2. When you transpose the L squared over, so when L squared comes here, to be what? L to the power negative 2. Are you okay? Which is equal to M. According to the law of indices, this is the power 1. They are multiplying. So when I add 1 plus negative 2, I'll get what? Negative 1. Then I have my T already to the power negative 2. See, they are the same. Are you okay? So that is that. It's very, very what? Simple. Now, I want to pinpoint out some things to you. In dimensions, that dimensional analysis or dimensional method, just note this. Inculcate this into your brain. The dimension of the following: velocity. Have you realized most at times when we are writing the dimension of quantities, we mostly employ velocity over there and acceleration. Most at times, acceleration. So acceleration is what? L. Velocity is L to the power -1, and acceleration is what? L to the power -2. When you just know this, you just have to just substitute and go your way. Because acceleration here is velocity over what time. So you just write velocity over t. You go your way, force, mass, acceleration. In that order. This is the end of the lesson. Solve this on your own. I'll come for the feedback. What is the dimension for speed? So speed and what? Speed. So for now, just speed. Speed and stress. Speed and stress. Bye bye.